All right, so we're doing a continuation of this question, all right, which says the data below relates to the number of successful sales made by a bulb salesman employed by XYZ Electronics, right? So we've been given the number of sales and our number of salesmen. This represents the frequency. So in our previous video, we found the mean, the model cells, we even found the median. Now we're working on computing the coefficient of variation. The coefficient of variation, this is the ratio of the standard deviation and the mean, all right? So we need to get our standard deviation to get our coefficient of variation, all right? So remember, the standard deviation, this measures how far or how spread our data is from the mean. Then our variance is that distance squared. It's the standard deviation squared. Okay, so that's what you must remember. All right, so we're finding our variance. Okay, we have our table here. We already got our midpoints. All right, remember 0 plus 10, 10 divided by 2, that's 5. 10 plus 20, that's 30. 30 divided by 2, 15. All right, so now we're going to square all our midpoints, which is done in this column. All right. Then we multiplied our frequencies with our midpoints to get this column fx here. Now we're going to multiply our frequency and our midpoint squared, which is x squared, in this column here. So 250 times 10, we're going to get 250 times 10. Oh, no, this one is easy. 2,500. Okay. 225 times 20. That's 4,500. Right? 625 times 30. 18,750. 1,225 times 50. You get 61,250. You get 2,025 times 40. 81,000. Then we get 3,025 times 30. We get 90,750. All right, so now we're going to total up this column. Right, so we say 2,500 plus 4,500 plus 18,750 plus 61,250 plus 81,000 plus 90,750. We're going to get 258,750. 750. All right, now we can see our formula here. We're going to input that. So we're going to say our variance, which is the standard deviation squared, right? And the standard deviation measures how far apart the data is spread from the mean. So we have 1 divided by n minus 1, right? N represents our total frequency. Our total frequency is 180 here, all right? So we want to say 1 divided by 180 minus 1, right? Then open brackets, all right? It tells us the summation of our frequency by our midpoint squared, f times x squared, which is this column here. So we have 258,750 right? Minus, all right? Then we have this summation of our frequency and our midpoint fx, which is here, this 6,300. We're going to square it. So it says 6,300 squared 6,300 squared. All right. Divided by 108. Okay. 1 divided by 179, you get 0. You get 0.00558. Okay, 180 minus 1, that is 179. So get 0.0055. We just say 0556. Okay, and open brackets here, right? 6,300 squared, it gives us 36 million. Hold on. 36,690,000. Divide that by 180. We get 220,500. So say 258,750 minus 220,500. All right. And then we're going to say, so let's do our operation in the brackets. 258,750 minus 220,500. We're going to get 38,250. And we multiply that by 0.0056 and we get 214.2. Right? That is our variance. And remember, the standard deviation is the square root of the variance. All right, that is, and as I said earlier on, it's just measuring how far apart the data is from the mean. All right, so we're going to get the square root of 214.2. Right, so it's S equals, right, so the square root of 214.2 gives us 14.63. Right, so that is the standard deviation. So our coefficient of variation, all right, our coefficient of variation, which is C, equals our standard deviation divided by the mean. All right, standard deviation divided by the mean. The standard deviation is 14.63 divided by our mean, which we calculated earlier, 35. All right, our mean is 35. Okay, the coefficient of variation, this is just a ratio of the mean and standard deviation. So I'm going to say 14.63 divided by 35, get 0.48, 0.42. 0.418, but we'll round it off to 0.42. Right, if you want to convert this into a percentage, multiply this by 100 times 100%, we're going to get 42%. All right, that's our coefficient of variance. All right, now we can also dig in a deep further, let's find our interquartile range. All right, so to get our quartile range, all right, all we need is this table here. All right, let's find our lower quartile. All right, so for our lower quartile, to find the position of the lower quartile, it's n divided by 4. All right, n represents the total frequency. Right, so let's start with our lower quartile. Lower quartile. All right, so we're going to say 180 is the total frequency n divided by 4. 45. So our lower quarter is on the 45th position. All right. So where can we find our 45th position? And find our 45th position in this class here. All right. So let me move this highlight here. All right. So our lower quarter, we can find it, the 45th position, and this is where we can find the 45th position in this class here. All right. The 45th position. All right. So what information do we need? All right. We need LQ, the lower boundary of the quartile class. All right. The lower boundary of the, let's say, cut here. Lower boundary of, lower class boundary of the lower quartile class. All right. So the lower boundary, as I said, the lower boundary is going to be 20. All right. The lower boundary is 20. Right. What else do we need? We already know the total frequency of the distribution. All right. We've already been told n equals 40, 180. All right. All right. We need the cumulative frequency before the quartile class. All right. Cumulative frequency before the quartile class. All right. So our quartile class is, our lower quartile class is here. So the cumulative frequency is 30. Okay. Give us 30. Right. And then we need the frequency of the quartile class. All right, so the frequency of the lower quartile class, the frequency of, yes, the lower quartile class is 30. And finally, the class width, right? As we've seen when we're calculating our median, right? The class width in this case is 10. CQ is just the class width of the quartile class, right? So we can now put this into our formula here, which will say Q1 equals, all right, the lower boundary of the quartile class is 20, 20 plus, all right, the our class width, right? So our class width is 10. Class width is 10. Let's see if I can just, all right, class width is 10. So our total frequency divided by 4, we got 45. So this n divided by 4 will be replaced by 45, all right? And then our frequency before our median, our quartile class is going to be 30. So this FQ minus 1 is 30. So in our parentheses or in our brackets, we have 45 minus 30. Open. 45 minus 30, right, divided by FQ, which is the frequency of the quartile class, that is 30. All right, and then we can do our calculations here. 45 minus 30, that's 15. 15 times 10 is 150. 150 divided by 30, that is 5. So we're going to say 20 plus 5. All right, and we get 25. So our lower quartile. All right, let's now deal with our upper quartile. Well, first thing we do is locate the position of our quartile class. All right, so it's 3n divided by 4. All right, so we're going to say 3 times the total frequency is 180 divided by 4. All right. Three times 180, we get 540 divided by 4, we get 135. Right, 100 and so its position of this is on the 135th position. And where will we find the 135th position? The 135th position, we're going to find it in this class. Okay, we find the 135th position in this class. So now we get the data that we need. The lower boundary, because we can start, already know n equals 180. Already aware of that. The cumulative frequency before our quartile class, one 180. All right, then the cumulative frequency before the quartile class, right? Cumulative frequency before the quartile class is 110. All right, so 110, and then the frequency of the quartile class is 40. We already know the class width is 10. All right, so we do Q3 equals, right, the lower, we start with our, let me bring the formula close by. All right, so the lower boundary of our quartile class, what's the lower boundary? Oh, I forgot to put that. The lower boundary LQ is 40. Okay, lower boundary of our quartile class is 40. Right? So I'm going to say here equals 40 plus, right? 40 plus. Our class width still stays 10, right? We did 3n divided by 4, we got 135. So in our parentheses, we're going to have 135. Let's zoom in a bit. Right, 135. The frequency before quartile class is 110, right? And the frequency of our quartile class is 40. All right. So 135 minus 110, that is 25. 25 times 10, that is 250. 250 divided by 40, we get 6.25. All right, 6.25 plus 40, we get 46.25. Right? 6.25 is our upper quarter. All right. All right. So now our interquartile range is Q3 minus Q1. IQR is Q3 minus Q1. Okay, that's 20. So we have Q1 is 25. So we have 46.25 minus 25. All right. So 46.25 minus 25. We get 21.25. Right. So that's how we get our interquartile range. The same interquartile range, you just divide this by 2 if the question asks for that. So thank you guys, and we'll see you next time.